Right account, we're solving multi-step linear equations. This is hopefully nothing new to you, but it's going to come with a little bit of a twist on some of these, and that's good. So, up in account, we got this first one. For the following problems, write a reason in your own words for each step, then explain what the solution means. So right here, they use the commutative property. Yeah. To move the three x's close to each other. Bam.
Can we turn the lights off?
I need them.
I can't see it.
You can't see that? Well, it's on your paper right there. Next up, right here, we can see that they combined like terms or simplified the expressions. Like terms. Then the next step up in here, they subtracted 6x from both sides. And this moves the x's to one side of the equal sign. And that now simplified again. And then the next step, it appears that they subtracted 5 from both sides.
Oh, it's just really light.
Sorry. Subtract 5 from both sides. And then, again, simplify. And then, that gave them negative 12x equals negative 24. They didn't really do anything there. So, yep, they divide both sides by negative 12. And then, that gives us the answer. Bam, there it is. Now there is one thing that they missed pretty badly up in here. They have clearly missed checking the answer. So they should go back to the original equation, plug x is 2 into that stuff and make sure that it is correct. In the meantime, we're good with where we are there. Well, right?
Yeah.
So like at these, this is where we start up in here. And then again, they've used the commutative property to move the 5x next to the 3x. This is a step that not everyone really needs, right? Most of the time, what we see is this v thingy. So this would indicate that we're combining the 3x and 5x to get that 8x. Now right here, some of you would notice that the two equations are equal, or the two expressions are equivalent. So, what kind of system of equations would that be? Well, it's the same equations, which would give us how many solutions? Infinite.
Oh.
Infinite solutions. So, right here, they subtracted 8x from both sides, and these two zero out. So when we get negative 7 equals negative 7, that's just always true. Since that is always true, we would have infinite solutions. So right up in here, right, again, they're going to combine the 4x and the 2x to get this 6x right here. Now we got 6x plus 15 equals 6x minus 7. And when we subtract 6x from both sides, the x's cancel out. And we're left with this 15 equals negative 7. Well, 15 equals negative 7, this is more like a question mark. No, that's false. In fact, it's always false. Therefore, this one would have no solution.
Then one is a one solution.
Let's look. So let's actually come back to this B step right up and count. So we can see that this is like having two equations. We got y equals 6x plus 15. And then over here we got y equals 6x minus 7. Now just like the bell work, these two equations have the same sloppage, but differing y-intercepts. Therefore, they have no solution. So how do we tell if there's one solution, right?
Yes. I got.
So if we look at these,
So you'll end up with an x equals another.
yes.
Okay.
Now we could have looked particularly at step B again. This one, it's kind of like we have two equations. Y equals negative 6x plus 5. And the other equation, right here, y equals 6x minus 19. Well, that right there shows that we have two different sloppages. Therefore, we would have one answer.
But it also has an x.
Yeah, right. So this plus, what was it, 211?
211.
Like at these?
Yeah.
All right, so to solve at these, to solve it, we'll look at this two ways,
Like
actually.
you know it's false, but.
Yeah, it's false because when you subtract x from both sides, you get 0 equals 211. Then that's false. Now, on the other hand, you had two equations, y equals x and y equals x plus 211. So that's two equations that have the same sloppage but differing y-intercepts. Therefore, there is no solution. So that's two ways to look at it.
Models never happen.
Possibly. We like models because they're so fun to draw. Up to this point, we have solved linear equations with a unique solution, one solution. In this lesson, we will encounter equations that, when solved, have infinitely many solutions and no solutions.
But we've already done that.
Well, that was for systems, though. Yeah, this model stuff is great. So, right here, consider the following model for the equation. So this would be an x right here. This is an x, 1, 2, 3. 1, 2, 3. Well, this 2 times that tells us that we have two sets of x plus 3, or two groups of x plus 3. That should sound really familiar from elementary school because that is what multiplication be. Now the other equation tells us that we got two x's, 1, 2, and then 6 ones. 1, 2, 3, 4, 5, 6. Now these are equal. Make some observations about the model above. Okay. So here's one thing that we should notice on these. I don't want that. Let's make this bigger. That's better. All right. For example, the two equations, the equation, the model. The model shows the same x's and ones. For both sides of the equal sign. Now solve the equation. Well, here's how this would work if we use principles of equality. So, I want the x's on one side. Well, I've got x's on both sides of this would be considered the equal sign. So I'm going to tag on a negative x radical and a negative x radical. But if I do it to one side, I got to do it to the other side as well. Well, these x's cancel and so do these. They become what they call zero pairs. And we're just left with the 6 radical and the 6 radical. Well, how do we get rid of those? Well, I would tag on a negative 6 and a negative 6 radical. And then these cancel out as well. And we're left with nothing on one side and nothing on the other side. So as it turns out, this one has infinite solution. I'll point this out here. Some of you guys notice that, yes, this equation is the same as this one after the distribution. Therefore, since we have the same expressions on both sides of the equal sign, they are the same, which would also produce infinite solutions. What happened when you solve the equation? What is it about the structure of the equation that led to the solution? We already explained that in part A. There's the same number of x's on one side as there is on the other, and 1's as well. Build your own equation that would result in the same solution as the one above. Alright, well there are a few. That's a good one, I like that. 0 equals 0, that's a pretty good equation right there. Well, what else do you guys got?
3 equals 3.
3 equals 3. What if we had, let's see on the equation, what if it was 4x plus 15? Oh, that would be good. 15 plus 4x, right? This would produce infinite solutions. What else? You guys got any more?
13 plus 2.
13 plus 2. Let's make that a negative 13 and a 2x, just to make it look a little bit more exciting. Well, then we would have maybe a 2x minus 13. This would work. That would work. So let me, 3x plus 5 equals 3x plus 15. That's very good. Yep, all of these would work. Solve the equation you built. What do you notice? All of these come out to really what we have right here, which is 0 equals a 0. Or maybe some of you would explain that they have the same exact expression on both sides of the equal sign. Let's draw some. This one should come out pretty good, because right here we got these two x's. Well, we got those two x's as well, then we got these ones up in here. 8 of those, and then 4 of these. Now the problem with these is when we tag on this negative x to cancel these two out, which means we got to tag on 2 negative x's over here to cancel these. Well, the x's are all goner, and then we got 4 equals 2. Now, some guys again wouldn't need to go any further. 4 equals 2 is good, but no, 4 equals 0. What the heck? See if we tag on 1 negative and a negative 1 and this negative 1 and negative 1 and this negative 1. See if we do it to the one side, we got to do the other side, right? Everyone loves the models. So these cancel out and these cancel out as well, and we get 4 equals 0. The problem with that is 4 does not equal 0. So this one has no solutions. Now we should point this out, right? If you take 2 times some number plus 8, can it ever equal 2 times the same number plus 4? No, because you're adding something different to something that is the same. So naturally they should be different. So solve the equation, we did that, no solutions. What happened when you solve the equation? Well, the x is canceled out, but then we got some number that does not equal some other number. Like 4 does not equal 0. What is about the structure of the equation that led to the solution? Well, the x's all canceled away, and then not enough of the numbers canceled away from one side of the equation. So that produces an unbalanced equation. So build or draw your own equation using tiles that would result in the same solution as the one above. We don't need to use the tiles. Then we'll solve it. But what kind of equations would this be? I mean, like the one above, right? Maybe 5 equals negative 5. I mean, that's not true. That's bad. But what if we had a 3x equals, I don't know, 3x plus 1? See, this one would do it as well. Do you guys have any?
X equals 2x.
2 plus 4x equals, that's close.
No.
That's close. Here's what we'll do. We'll do 2 times 1 plus 2x. See, now this would produce infinite solutions because they're the same. So just add 1. Add 9. Add 91. Doesn't matter. It will be different. Okay. So solve the equation you build. What do you notice? Again, the x's will cancel out and we're left with a number that does not equal the other number. So with that, we should be able to not solve these completely, but know how many solutions there will be. Like on a these. See, if I distribute on this first one, if I distribute this 3 into the parentheses, then I get 6a minus 3. Well, the other side was 6a minus 3, so there's not really any need to do any more of this. I have one expression that is equal to the other, and they are the same. Therefore, this one has infinite solutions. Well, right there, yeah, if we put plus 0, now we got the same sloppage, different y-intercepts. This one is the Shakespeare ending because there's so much in common, but they will never meet. It's unfortunate. So, no solutions. Bam. So when we combine this 8x minus the 2x, we get 6x. Of course, we still got that plus 4 equals 6x minus 1. So again, we can see that there's the same number of x's on both sides, but we've got adding a different number to both sides. So this one is going to have no solutions. All right, take a moment, look at this one. What do you guys think?
There's one solution.
Why?
When you solve it down, you get n equals -5.
Okay, and you can do that, right?
Yeah.
Now, we could again look at this as one equation, y equals 5m plus 2. And then the other one is a different equation, y equals 3m minus 8. And we can see that with the different sloppages, they'll produce one solution, which was -5. It didn't ask us to solve, but we could. All right, number 7, how many solutions? Let's take a look. Let's distribute this and see where it takes us. 6a minus 24 and 6a minus 24. Again, this is the same. Therefore, we would have infinite solutions. Bam. Number 8. These ones kind of can be a little confusing. If I separate this fraction into two fractions, then I'd have 3x over 3 minus 12 over 3, which simplifies into x minus 4, and this equals x plus 4. So again, it's like we have two equations, y equals x minus 4, and then over here, y equals x plus 4. Same sloppage of 1, but differing y-intercepts produce no solutions. So again, I would split this up. I got 2x over 4 plus 2 over 4, which simplifies into x over 2 plus 1 over 2. And the other side of this would be x over 2, it's an x, plus 1 over 2, which, again, these are the same, so infinite solutions. All right, what do you guys think about this one? This one's a little tricky with that fraction stuff.
Would it be one solution? No. Yes?
Yes,
Yes, it would be one solution.
it would.
Because that's x over 5, not
That's
just
very
x,
good.
so,
X over 5 plus 1 over 5. Now we got differing sloppages, because this is a sloppage of 1. This would be a sloppage of 1/5. Different sloppage, one solution. All right, this one, again, we'll distribute this 1/2 to give 1/2 x. Minus 1/2 times 8 is 4. So again, we got the same equation here as right here. This is different. 1/2 x can be x over 2 as well. So this one,
Disney ending.
that is correct. Disney ending, infinite solutions.
So does 1/2 x equal, x over 2? Wait, I think I did that.
Number 12, consider the expression 4a minus 12. Write three different expressions that, if set to equal 4a minus 12 would result in the equation having infinite solutions. So if we had 4a minus 12, this could equal, again, it should give us infinite solutions, right? So one of them, hopefully, is just 4a minus 12. Another one, we could use distribution and make this 4 times a minus 3. Or you can split up some of the stuff. So 4a minus 12 can be equal to, I don't know, a plus 3a minus 12. Or you can split up the 12. That's pretty good. What about this next one? X plus 1, we want 3 different expressions that if they're equal would have no solution. So if I had x plus 1, maybe I can set this equal to x plus 2. So if I had x plus 1, maybe we make that equals to, I don't know, x plus 82. That would work. And we can continue this. This one isn't too bad. Maybe 3x minus 2x. That would work. As long as you don't add 1 to that, you're good. But you could add anything else. Consider the expression 2x plus 6. We want 3 ones that would, if they're equal, would give us one solution. So maybe 5x. Maybe 5x plus 1. Maybe we got 2x plus 6 equals just x. Maybe it's 2x plus 6 equals 200, 1,200, 12,000. It doesn't matter as long as we don't have a 2x on both sides, then we're good. Determine whether the equation 7x equals 5x has one solution, infinite solutions, or no solutions. If it has one solution, we'll figure out what that is. So if 7x equals 5x, there we have two equations that would have differing sloppages. It should have one solution. So it is one solution. We just need to figure out what that is. So we got 7x equals 5x. Bam, we're going to subtract, I'll say 5x from both sides. And then I get 2x. 2x equals 0. And when we divide by 2, we see that x equals 0. And that should be pretty easy to solve right there. 7 times 0, 0. 5 times 0, 0. So x is 0. Alright, let us solve at these. So I would say let's add 1 to both sides, maybe. Maybe I would say subtract x from both sides as well. So these x's cancel, these ones do. This negative 1 and positive 1 cancel, so we're just left with 0 equals 2. And 0 does not equal 2, so no solutions. If you had, let's say you had subtracted 1 from this one, and then subtracted 1 from here, then you would have had negative 2 equals 0. It's the same thing though. Negative 2 does not equal 0, so again there would be no solutions. Yeah, that's a good, very good question. This one's not too bad. So, with that question, which side do you guys want the x's on? Because it doesn't matter. The right side. So let's subtract these 5 x's. And then if we do it to one side, we got to do it to both sides. So subtract 5x right account. So now I got negative 10 equals 10. But now I got minus 10x. And I don't want 10 minus 10x. That's garbage. I don't want this 10 there, so I'm going to subtract 10 from both sides as well. Leaving us with negative 20 equals negative 10x. So finally, we'll divide both sides by negative 10. And we get x equals 2. Now again, you could have done it the other way. If you had put the x's on the left side, you would have had 10x equals positive 20. That's the only difference. But the answer would have come out the same, just Again, you would have had x equals 2 instead of 2 equals x. Both of them are good though. Let's try this one. Now if the fractions don't come out well like these ones will, then you may want to get rid of the 2 instead. So what this means is that before we split this up into 2 separate fractions, right here I'm just going to get rid of the denominator by multiplying both sides by 2. So these 2's cancel out. Now I've got 2x plus 8 equals, after distribution, I get 2x plus 8. Now again, for some of you, there's no need to continue on, but for some of you there is. So if I subtracted 2x from both sides, then these cancel, but so do these, and I have 8 equals 8. And if I subtracted 8 from both sides, I would get 0 equals 0, which indicates that there are infinite solutions. Bam. Alright, let's distribute that 1/3 into the parentheses. So that would be 1/3 x minus 2/3. And yes, 1/3 x is the same as x over 3 minus 2/3. Now this should be equal to x over 3 minus 2 over 3. This is the same equation on both sides.
Can we just get rid of the
On both?
denominators because they're all 3's?
Yes, you could. And what that means is we could write this as x minus 2 equals x minus 2. Again, it's the same. So this one has infinite solutions. Alright, with this one, what I would do first is combine my like terms on the left side. So if I had 3 v's and 2 v's, that would give me 5 v's. And then I got this plus 5 right here. And that's the left side of that equal sign. On the other hand, I can distribute this 5 in right here. 5 times 2 is 10, plus 5 times v is 5v. Now again, some of you guys wouldn't need to go any further, but let's do it anyways. I'm going to subtract 5v from both sides. Oh, that's not an x. V. Minus 5v from that side as well, and these cancel out as well as these v's. And I'm left with 5 equals 10. Well, 5 does not equals 10. That's a false statement. So this one would have no solutions. We'll get there. What is it about the structure of the solution that leads to one solution, infinite, no solutions? Provide examples to support your claim. All right, one solution. You'll just have different number of x's on both sides of the equal sign. Infinite solutions, you have the same number of x's but the same number of numbers as well. Or you may end up with something like, so this is for infinite solutions. You may end up with something like 8 equals 8. Sometimes it's negative 8 equals negative 8. It doesn't matter if it's negative or positive. As long as it's the same on both sides of the equal sign, then it's infinite solutions. So no solutions is when you have the same number of x's like these, but you're adding something else that's different, like 5, and maybe you're adding 3 over here. This one has no solutions, because when we take away the x's, we'd get something like 5 equals 3. And 5 definitely does not equal 3. Number 18, we will distribute the 4, giving us 4m minus 3, no, that's 12, minus 12, equals 10m. And up in here, we're going to distribute this as negative 6. So that becomes negative 6m minus 12. And when we combine the m's on the right side, 10m minus 6m is 4m. That's good. So we got 4m minus 12 equals 4m minus 12. Now, some of you guys stop right there, and that's okay. But let's say that we wanted to move the m's to one side, so let's subtract 4m from both sides. So these cancel out, but these cancel out as well, leaving us with negative 12 equals negative 12. Well, negative 12 does equal negative 12, so that one would produce infinite solutions. Number 19, we'll distribute the 4 right here. 4x minus 16 equals 4x minus 16. And yes, that's as far as we need to go. Infinite solutions. Alright, what do you guys think about 20?
No solution. No solution. It's no solution.
It is no solutions.
Because that's, there's no times equals
None solutions.
5. So that'd be
21.
one solution. Wouldn't it?
What is it?
Is it? No, there's
That's
no
correct.
solution. No.
None solutions again. Alright, this is a good one. 23. Here's the problem is that sometimes we forget that this is a negative 1 radical. So when we distribute it into the parentheses, we get negative 4a minus 8. Of course, we still have that 5 up in front, but it ends up being the same as both, as the other side, so infinite solutions.
I got that right.
Alright, for the following problems, write a reason in your own words for each step and explain what the solution means. Let's take a look at these. So in this problem, we can see the first thing they did is they used the commutative property to move this 3x over here. So right there. And then from radical, they combined those two to get that 6x. And then of course what we would have done, and it's kind of what they did as well, is they subtracted 6x from both sides. I mean, they showed it a little bit different, but it is the same thing. Which gets rid of this 6x radical, see, because these two cancel out. And so you're left with that negative 19, negative 6x minus 6x is negative 12x. And then from radical, we would subtract 5 from both sides, just as they did radical from both sides. Well, that gives us negative 24 up in here. And you got negative 12x equals negative 24. This. And then you divide both sides by negative 12, and you get x is 2. So I prefer to show the work than to explain all that stuff, but either way, it's good. For this problem, right, so I'm going to skip that first step A, and I'm just going to combine the 3x and 5x to get that 8x radical. Question. So what we would do is we would subtract 8x from both sides, right? And they've just shown it horizontally instead of vertically like we do. Minus 8x and minus 8x right there. It's the same thing though. And what happens right up there is that we get rid of the x's. So that's a 0 and that's a 0 pair radical. So what are we left with? We got this negative 7 and then negative 7.
So 0
We're going to bring them down.
0.
Well, we can just say negative 7 equals negative 7, which would...
Also 0, 0, 0. I mean...
Which would... What would the answer be for this one then?
Oh, 1. Divided them.
Because it's not really 1. It's not negative 7.
0.
The question really is, does negative 7 equal negative 7? That's true.
Because the left side is always the right side.
Now, since that's the case, what we end up with is infinite solutions. Now, if we remember what we went over last time, we can come up here into this stuff. Let's look specifically at this line B. Now, we got these two equals parts right here. I got two sides of this equal sign. I got this 8x minus 7 radical. So that'd be y equals 8x minus 7. And then on the other side, we got this 8x minus 7. We could write that as y equals 8x minus 7.
Yeah.
Well, see how we have two equations that are the same?
Yeah.
So what we learned last time is when we have the same equation, it's the same line if we were to graph it, so it has infinite solutions.
So if it's the same right off the screen.
Alright. On this one, again, I'm going to skip part A and just combine the 2x with the 4x to give us the 6x radical. See, and then we got these two equations. Now notice this one, we have the 6x plus 15 equals 6x minus 7. And so what would we do? We would subtract 6x from both sides, which is what C is doing. And then, after that, we get a 0 pair from here and a 0 pair there, which leaves us with 15 equals negative 7. Well, last time I checked, 15 is not equal to negative 7. That's not true. That's false. Since it is false, instead of infinite solutions, it's no solutions. Alright, so what does this mean? Number 1 had one solution, x was 2, if I remember right. 2 had infinite solutions because we had the same line. And 3 has no solutions because they're parallel lines that never touch, okay? Again, we can go back up in here. Let's go to step B and just look at these, okay? We got y equals 6x plus 15. Now this needs to look pretty familiar, you guys. Then we got this 6x minus 7. So that would be y equals 6x minus 7. Just like the bell work, we have two lines that have the same sloppage, but we got different y-intercepts. Therefore, they are parallel. They will never touch. No solutions. Number 1, we try to get the x on its own side and make it 1x, and it was x equals 2. So that's one solution. If they cancel out, then it can be either infinite solutions or no solutions. It depends. Let's do number 4. You guys should remember this stuff from 7th grade, but of course no one really does.
Remember it.
Alright, Josh likes it so much, we're going to do it. So, on this one, I guess let's start first with that equation. Alright. Alright. So right here, we got these x's, x, and then 3 1s, but up in here it says we got two groups of that. So we got x and 3 1s. That's multiplication, that's what distribution is. You guys need to remember that because, well, it's pretty important because sometimes people add or subtract that garbage. And then on the other side, we just have 2 x's and 6 1s, like these. Oh, it's very nice. Well, from right here, we want to get rid of those 1s, which would be great, so I can have 6 negative 1s. But we have to remember it's an equation, so if we do it to one side, we got to do it to the other side as well. Right here, I'm getting rid of those 6 because I just want to compare x's for now. The problem is that when I do these, all of these 1s up in here, they're going to cancel away. So what I'm left with is the 2 x's and the other 2 x's. And so to get rid of those, what I would do is I would need a negative x, and I would have this negative x, and these would cancel. And if I tag on another negative x to both sides, bam, these also cancel. So what am I left with? Well,
Nothing.
on the left side I got 0, and on the right side I got 0, and they're equals. Well, does 0 equal 0? Sure do.
Yes, it does.
So yes, this one ends up being infinite
Boom.
solution. Bam, there it is. So we have to remember if there's the same number of x's on both sides of an equal sign, after we've simplified, then the answer either has to be infinite solutions or no solutions. It depends on what number remains. And right here, we could have ended up with 6 equals 6, but we canceled them out and made it 0 equals 0. And 0 does equal 0, so it's infinite solutions. Oh. I was thinking it looked more like an owl, like if that was the beak. Then you,
Yeah.
then you got
So like
a,
a huge owl.
yeah, like an owl, right? It's got wings right there.
It's a penguin.
Okay, penguin's good. Alright, build your own equation that would result in the same solution as one above. So we want to write an equation that would produce infinite solutions. You guys take a moment and write those. Alright, you guys, there's several things you could have done for this, by the way. Here's one, 4 equals 4, done. But I think in your minds you're making it very complicated. Something like these. Maybe something like negative 3x plus 5 equals negative 3x plus a 5.
Wait, we could have just done that?
That's all I did.
Oh, I did 3 parentheses x plus 1 parentheses equals 3 x plus 3.
Oh, that's actually a very good one. 3 times x plus 1 equals 3x plus 3. Yeah, that's really good.
Two
I did it.
X plus 2 equals x plus 2?
No, it equals 2.
Oh, okay, I got you.
Equals 3x.
Yeah. Plus 6, that would work as well.
That's what I did.
Now, so you guys structured it like the one above. That's okay, that still works. So the question is, what do you notice? Of course, again, the x's should be canceling out, and you should end up with some number equals the same number on the other side of the equal sign. Alright, let's get rid of those ones then, because these are x's and these are ones. And they're all positive, which is extremely convenient. And then we got these two x's right account. Let's get rid of the ones. So, up in here, I can see if I get rid of these four, that will just be all of them up in here. But if I do it to one side, I got to do it to the other side as well. So right account, these four cancel out, and then these four cancel out. So I am left with these four. But let's look what happens when we get rid of the x's now. Well, these x's cancel away. But if I do it to one side, I got to do it to the other side.
4 equals 0?
4 equals, or no, 8 equals.
And yeah, so you guys notice, that's good. This is 4, and it equals, there's nothing left on that right side.
0.
Does 4 equal 0?
Yes.
No.
No solution.
4 does not equal 0, so yes.
I was right.
No solution. The reason why there's no solution is, if we look at just what we started with right here at the top.
To me, it was going to be.
Let's say that you take 2 times something, and then add 8. Could that ever be 2 times the same thing, plus 4?
No.
No. It can't.
Oh, so if the x is left, then it's a solution, right?
Solutions on the other one, 'cause there's.
Alright, so that one was no solutions. Now what you guys need to do is make an equation that would produce no solutions. Alright, what do you got? Okay.
I got 0 equals -1.
That works. Someone else? Anyone?
8x plus 4, plus 4 equals 8x plus 3.
Bam, that works. That's very nice. Another one? Yep.
0 equals -2.
0 equals -2. Bam, that works. Any others? Alright, that's pretty good. All 3 of these would produce no solution. Again, the reason, what do we notice, is that the x's cancel, and we're left with 2 numbers that are not equivalent. I don't know what you said, but I'm gonna read this. Without solving completely, so we don't need to solve these. We just need to determine how many solutions there will be. Alright, number 3. How many solutions?
None.
It's not.
12.
Infinite.
It's solutions. Infinite solutions.
Infinite solutions.
What's why?
After distribution, you will end up with the same equation on both sides. 6a minus 3. Number 4. Very good. None solutions. Alright, what about a D's? Very good. This one's a nunner. This one? 1 solutions.
Yes, I got it. But it doesn't have the same y-intercept.
Oh yeah, but they have different sloppages. As soon as you have different sloppages, automatic 1 solution. Alright, what about a D's?
No solutions.
This one has
Infinite solutions.
infinite solution. After distribution, you should get the same exact values. Let's find out. For this one, here's what we should do on this is, we have 1 fraction. Let's split it up into 2 fractions. And if we simplify these, we get 1x minus 4. Now, right there we got the 1x and 1x, so they would cancel out. The problem is I got -4 equals 4, which is false, none.
Wait. Oh, because it's -12.
Alright, here's another way we can do this. It's kind of like treating this as though it were a proportion. So if I multiply this side by 2, this is cross multiplication, you guys. Then I get rid of these. So then I got 2 times 2x plus 2, so that's 4x plus 4. And then over here I got 4 times x and 1, so that's 4x plus 4. These are the same, so this is infinite solutions. That one I was just treating like a proportion. If you wanted to, you could split these up into two fractions. So you can make this 2x over 4 plus 2 over 4
That's super nice,
equals
right?
x over 2 plus 1 over 2. And you should get the same thing.
You always.
Number 10,
Yes.
this one, specifically on the right,
One solution.
this one becomes x over 5 plus 1 over 5. So the coefficients of x are different. There's one solution.
There's one solution.
What's out? Just fun.
All right, you guys try this one. Infinite solutions. Sorry, is that not? I was close. All right, consider these expressions. We want to write three different expressions that if it's equal to this stuff, this first one would provide infinite solutions. So 4a minus 12 for infinite solutions would have to be equal to 4a minus 12. Now that's one of them, but it wants two others. So 4a minus 12 equals...
4a minus 6 plus 6.
8 minus 4.
That's close. That's
8a
close.
minus
2 times 2a minus 6.
Say that again?
2 times 2a minus 6.
That works. There should be one more though. 4. Let me write this down. 4a minus 12
Equals
equals...
4a minus 12.
Oh, we already did that one.
8a minus 24.
8a minus
4a minus 6 plus 6.
I'm just going to make that a 4 and make it a minus 3. All those work. Of course, there is more. Some of you guys know that I saw that you're splitting up either the minus 12 or the 4a. That's good. Those would all work. All right, what about this next one? Now we're looking for no solution ones, right? So x plus 1 would be equal to
x plus 0.
x plus 0. Well, I'm just going to make it x. What about x plus 1 equals
X plus 2.
x plus 2?
X plus 3.
What about x plus 1 equals
X plus 3.
X plus 1/16.
X plus 4.
negative 13? That's close.
X plus 14.
We need to add an x, that's all. This one we want one solution, so 2x plus 6 would be,
Equals
x would work.
Yes, sir.
What about 2x plus 6 equals,
Wait.
Right.
2 parentheses x plus 1.
4x minus 8 would work. What about 2x plus 6 equals,
You go with 4x minus 8 words.
hold on, what's this one?
34x plus 90.
34x plus 90.
Why would 4x minus 8?
So the main thing we're looking for right here, again, is that these have different sloppages. That is all we need to produce one solution.
Solution.
All right, 15 right here. We just want to know if there's one infinite or no solutions. Right here,
1.
one solution, very good. And now it wants us to find the solution. So 7x equals 5x.
Oh, good.
So if I subtract 7x from both sides, or 5x, it won't matter. Then this becomes a 0. 0 equals negative 2x. Divide both sides by negative 2. X equals 0.
What?
X equals 0.